Dear class 10, we'll continue chapter number 8, that is circulatory system. So in the last session, we talked about, the composition of blood, where we had plasma and, blood corpuscles. So with regard to the blood corpuscles, last time we just finished RBC, okay, red blood cells, which are also termed as erythrocytes. Today in this session, we'll talk about another blood corpuscle, that is WBC. All right, that's what WBC. So WBC is also termed as leukocyte. Leukocyte. All right. So this WBC or leukocyte is the one which contains nucleus even during its maturity, unlike RBC. That means RBC during its maturity loses its nucleus. All right, and this WBC or leukocyte contains no hemoglobin. Okay, it does not contain hemoglobin. Okay, so unlike RBC, this WBC doesn't contain hemoglobin. All right, then it is much larger than RBC in size. That means with regard to the size, or as far as the size is concerned, the WBC or leukocyte is much larger than RBC. All right, and it is much less in number than RBC. So yeah, some of the things that you have to know out here between this RBC and WBC, which can also be considered as the comparative points or the points of differences between this RBC and WBC. All right. So as far as the number is concerned, WBC is, the number of WBC is much less than the number of RBC. Okay, so in the last session we talked, or we just had a discussion on it, that RBC is found to be about 5 million per cubic millimeter of blood. Okay, that was the number of RBC. All right, but the number of WBC ranges between 4,000 to 8,000 per cubic millimeter of blood. Okay, all right, the number of WBC ranges between 4,000 to 8,000 per cubic millimeter of blood. All right, amoeboid shape. Amoeboid shaped. Okay, amoeboid shape is almost like this. The shape is like this, amoeboid shape. Okay, the shape of WBC is like this, amoeboid shaped, having, or which can even produce pseudopodia. Alright, pseudopodia. Pseudopodia, in fact, actually are the false feet, which we usually find in amoeba. Okay, and that we discussed in our previous class. Means even in class 10 we discussed about it. So the shape of WBC is like this, amoeboid shaped, which can even produce pseudopodia. Okay, with the help of which this WBC can ooze out. Okay, can squeeze out through the wall of capillaries into the tissue fluid, or into the tissue cells or tissue fluid. Okay, they can come out into the tissue cells. In fact, this WBC can ooze out, and that process of oozing out, that process of coming out of the wall of capillaries into the tissue cells actually is called diapedesis. Okay, this is a process by which your WBC with the help of pseudopodia ooze out, okay, or squeeze out through the wall of blood capillaries into the tissue cells. So that process is called diapedesis. Okay, that means that capacity this WBC has got. All right, then based on the shape and other characters. Okay, based on the shape and other characteristics, this WBC can be broadly categorized into two groups. Okay, they are, one is granular. One is what? Granular. Okay, granular. The other one is non-granular. Granular and non-granular. All right. So basically, this your WBC. We can write like types of WBC. Basically, WBC or your leukocytes are of two types, that is granular and non-granular. These granular are further classified into three categories again. Okay, your granular is further grouped into three categories. They are neutrophils. Okay, they are neutrophils. There are 5 different kinds of your WBC in fact, but these 5 different types of WBCs or leukocytes have been grouped into these two categories further. Okay, that is granular and non-granular. So under granular, number one is your neutrophils, which constitute 62%. That means 62% of the that your WBC in the given volume of this one, particularly your blood, your 62% you find neutrophils only. Okay, neutrophils 62%. Then number 2, eosinophils. eosinophils. Eosinophils, that constitute 2.3%. 2.3%. All right. And number 3, we have basophils. We have what? Basophils. Okay, what? Basophils. So which constitute 0.4%. Right, 0.4%. So these are the 3 different kinds of WBC or leukocytes that come under granular type. Then your non-granular. This non-granular is further classified into 2 groups. Alright, so they are, I'll just continue from here. That is number 4, lymphocytes. Lymphocytes. Alright, lymphocytes that constitute 30%. Lymphocytes. LIMPHOCYTS, lymphocytes, 30%. And number 5, monocytes. Monocytes. Okay, monocytes. So that constitute 5.3%. See. So these are the 5 different kinds of WBC or leukocytes which have been in fact grouped into these 2 groups, that is granular and non-granular. Neutrophils, eosinophils, basophils that come under granular, and lymphocytes and monocytes that come under non-granular. So these are the types of WBC or leukocytes. Alright, then we'll talk about origin and lifespan of WBC. Okay, origin. Then origin and lifespan. Origin and what? Lifespan. Okay, so origin. This WBC or leukocytes are produced or formed. They're in red bone marrow. Okay, they are producing red bone marrow. Red bone marrow. Alright, red bone marrow. Then lymph nodes. Lymph node. Alright, what is lymph node? I'll just show you lymph node. It is here. So there on page number 91, you can see this diagram here. So here you can see the lymph nodes out here. So in this region also that your WBC is formed. Okay, and they are sometimes also formed in liver and also in the spleen. Okay, let bone marrow, lymph node are sometimes even in the liver and in the spleen. So these are the places where WBC is produced. Alright, and they can they have or they survive for about 2 weeks. Okay, about what? 2 weeks. 2 weeks. About 2 weeks. So their lifespan is about 2 weeks. There are different kinds of, this WBC, as you have just come to know, and they have different lifespan. But in an average, the lifespan of WBC is about 2 weeks. Okay. Now, based on WBC, that means in connection with WBC or white blood cells, there are two common diseases. Okay, that means there are two common diseases which are related to WBC. That means there are two common diseases which are caused due to the problems there in WBC. Okay, with regard to the the infect number, because of the very abnormal increased number of WBC and abnormally decreased number of WBC. There are, based on this increase and decreased number of WBC, there are two common diseases. So they are leukemia. Okay, leukemia. So leukemia is a fatal disease. In fact, it is a cancer. It is a cancer of the of the tissue forming WBC. That means WBC responsible for forming the tissue. Okay, so it is a cancer of the tissue forming WBC, which whose number increases abnormally. Okay, that means the abnormal increase of the number of WBC takes place in this particular disease, in this particular problem, which is called leukemia, is a kind of cancer. So, and this increase in the number of WBC takes place at the expense of RBC. That means at the cost of RBC. Okay, at the cost of RBC, this number of WBC increases. Okay, which is not good, and that usually cannot be cured. But the ultimate solution of this problem is the blood transfusion. Only the blood transfusion is the remedial step to control this problem. Otherwise, it is in fact a fatal disease. Alright, that is leukemia. Then we have another problem, leukopenia. Okay, leukopenia. So Leukopenia, leukopenia is another disease of WBC where the number of WBC abnormally decreases. In the above case, it abnormally increases at the expense of RBC, but in this case, the number of WBC abnormally decreases, which is also not good. Okay, so these are the common diseases of WBC. When something goes wrong with regard to the number of WBC, then these problems are seen, which are called leukemia and leukopenia. So this is all about WBC. Okay, now let's talk about the functions of WBC. Functions of WBC. Okay, the main function of WBC is to fight against the germs. Okay, which is directly related with the immunity of the body. All right, so that means whatever kinds of foreign substances enter the body, and they are traced, they are checked by these WBCs. Okay, that means this is the one which is directly connected with your immunity. That means it defends you. All right, this WBC defends you from the different kinds of disease causing germs. All right, so that's the basic function of WBC. So how is it connected with the immunity of the body? That means how does it defend us from the different kinds of germs? Okay, so let us talk about it. So there are three ways. There are three ways. That is, First one is your phagocytosis. What is that? Phagocytosis. 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 Okay, is the first type of, the function it gives or it does. Okay, which is also a kind of defensive mechanism. Alright, so in this what happens is that especially, the most of the WBCs, in fact, okay, but particularly there we find what you call your neutrophils and neutrophils, in fact, particularly neutrophils, Okay, there are 5 different kinds of that WBCs we have discussed. So most of the WBCs exhibit this process called phagocytosis, but particularly here we find neutrophils are the ones which engulf bacteria. Okay, which engulf bacteria. Let us say this is your suppose this is your WBC, or let us say neutrophil. There is bacteria somewhere here, suppose. Alright, this suppose bacteria. It engulfs such bacteria or any solid particles, any solid foreign particles which are going to cause damage to your body. Alright, so these are immediately traced by WBC and engulf like this. Alright, so that time it produces pseudopodia and engulf it like that. That means here these bacteria are trapped inside and are digested. So this mechanism, this defensive mechanism actually is called phagocytosis. So that way it makes such solid foreign particles or disease causing bacteria or germs are checked or killed. So that way it defends us from the problems causing germs or foreign substances. This is called what you call your phagocytosis. This method is called phagocytosis. Sometimes what happens is that we can see the increase, though we cannot see, but through the blood test we can make out that the number of WBC being increased up to 50,000 per cubic millimeter of the blood. Alright, if so that way the number of WBC has increased, okay, it indicates some kinds of infections in the body. Okay, suppose if the number increases up to 50,000 per cubic millimeter of blood, there is something wrong in the body. That means some infection is there inside the body. Okay, whatever it is, but as far as this phagocytosis is concerned, the neutrophils, particularly neutrophils, engulfs us bacteria, disease causing germs and digest them inside and make them inactive, or make them what you call your inactive, or make them having no capacity of causing damage to the health. So that way it protects us. That is called phagocytosis. Second, we have inflammation. Another problem also sometimes we see inflammation. Okay, inflammation. So inflammation is seen usually in the injured part. Sometimes the body somewhere gets injured. So that time what happens is that bacteria might go inside. Bacteria invade into such injured part. Then start causing the problem there. Okay, start causing the problem there inside with some symptoms, with some characteristics there, like redness of the wounded part. All right, or there what you can also see there is that swelling, okay, with acute pain. All this thing is seen, which is called inflammation, in fact. Okay, so that time your WBC here, when the inflammation takes place there, when it is infected, in fact because of the invasion of the germs, so there WBC, particularly monocytes and neutrophils, monocytes and neutrophils, these two particular types of your WBC, monocytes and neutrophils, go there and 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 they ooze out. They ooze out through the walls of capillaries or through the walls of blood vessels into the your what do you call it, tissue cells. Okay, into the tissue cells and fight them. Okay, they come out of the blood vessels. They come out of the wall of the that your blood vessels and go into the go into the tissue cells. All right, go into the tissue cells and fight them. Okay, so that method, as I've already told you, is what? Diapedesis. Diapedesis. Okay, by the virtue of this, okay, diapedesis, they come out of, or they ooze out through the walls of blood capillaries or the blood vessels into the tissue cells and fight those germs, fight those bacteria which are causing infections there in the wounded part or there in the injured region. All right, so that process of coming out or oozing out of the that your blood vessels into the tissue cell is called diapedesis, which I told you before also. All right, so that way they come out and fight the germs and are made them inactive, or they are killed there. So that way we are protected. All right, so there a literal fight goes there inside between the germs and these WBCs. Alright, so that time many of the WBCs may be killed, alright, along with the tissue cells. So on those killed WBCs and the tissue cells by the bacteria, because it's not that bacteria only are killed by them, but they are also killed by bacteria. So that time what happens is that these white blood cells along with the tissue cells are seen in the form of pus. In the form of what? Pus. PUS, pus. Okay, that in Nepal we call it peep, something like that. So that's all because of the death of these neutrophils or monocytes during the time of fight between them and bacteria. Okay, so this is how somehow it protects. Another function of WBC is that is formation of antibodies. Formation of antibodies. Okay, formation of antibodies. So white blood cells or leukocytes, especially lymphocytes, produce a kind of chemical called antibody or antibodies. Okay, so these antibodies kill the disease causing germs or neutralize the poison produced by these disease causing germs. All right, so so that way this WBC protects us from the different kinds of diseases. All right, so that's why vaccine is prepared. Okay, what is vaccine? What is vaccine? So vaccine actually is a weakened germ. Okay, weakened or dead disease causing germs. All right, and when it is introduced into our body, all right, so these germs going inside our body influence these lymphocytes, okay, or influence this WBC, so that these lymphocytes WBC produce these chemicals called antibodies, and these antibodies will always be kill them or make them inactive, okay, or neutralize the poison produced by them if they are still alive, and these antibodies will remain in the body for throughout the life. Okay, they are in the body. So in near future, if the germs of that particular disease enter the body, then these antibodies will kill them, okay, or will neutralize the poison produced by them, so that you will not be affected by that disease again. Okay, so these antibodies will remain forever in your body. Okay, that's the reason why the vaccination is done. Vaccination means the process of administering the vaccine into the body is called your vaccination. All right, so this vaccination actually is done to influence these lymphocytes or WBC to produce antibodies against that particular disease. Alright, so that's why the vaccination is done. So these are the three different functions of WBC, which means they are directly related to our immunity. Okay, that means our immunity is directly dependent on WBC, which means WBC protects us from the different kinds of diseases. Alright, so this is all about your WBC. Okay, we'll do only this much today. Okay, thank you very much.